Hello and welcome. Before we continue explaining how wind turbines and the rotor blades of wind turbines are working, we would like to explain why a rotor of a wind turbine is rotating, and that is almost the same why airplanes are flying. And that's the reason why in this video we will explain how airplanes are flying. And I try to make a sketch of such a wing of an airplane. And then it is always a bit of shape like that. And we assume that the airplane is moving in that direction. Or when we consider a wind turbine, the wind turbine is not moving, but then the air is moving towards the wind turbine rotor profile. And then it is the case that always the way the air needs to go above the wing is longer than the way the air needs to go under the wing. And that's the reason why the air is faster above the wing than it is below the wing. Because when they meet then here in the end of the wing again, that means the air above must be faster than the lower.
Ingo, this is a very romantic way to describe an airfoil movement. But I have to disappoint you. That's kind of wrong. So what we should do is to draw down a little heart for this romantic explanation, and then we should forget it.
Really?
Yes. Do you want me to explain it to you?
Okay, then explain you how it really works.
Okay. So you were talking about a longer way. So if we draw down some streamlines, it will separate above and below the airfoil wing, but the fluid parts above the airfoil are much faster than they are beyond. So they will not meet. So the different way is not a good explanation. This is due to the fact that in former times we had airfoils like this. And there you have streamlines again above and below. And here you have the same expectation. So you have very fast fluid parts above the airfoil and slower parts beyond the airfoil. And there you have the same ways. So this is not a good explanation. But what is very important is the curvature of the airfoil. So when we look onto the flow around the airfoil, we see the streamlines which are following the airfoil, above the airfoil and below the airfoil. Why do they do that? Why don't they just go straight? This can be a solution as well, but they do not follow straight, they follow the curvature of the airfoil. So look on this physics and try to find an explanation for it. So again, we draw some streamlines around the airfoil, above the airfoil and below the airfoil, and look onto the path. And when we have a circular way, you usually have forces following the circular way, which you may know for centrifugal forces. So you have centrifugal forces acting on the little parts of the fluid, of the air, and you have small forces and big forces in this direction due to the circular movement above the foil and below the foil as well. So you have the centrifugal forces acting on the fluid parts, on the little fluid or air parts. And when you have forces, you have forces against it. Like Newton said, he said it in Latin, it's actio to reactio. So you need a force against the centrifugal forces, and these are pressure gradient forces. So we draw pressure gradient forces, maybe in a green color to see it better, working in the opposite direction. So we have pressure gradient forces acting in the opposite direction to the centrifugal forces on the above the airfoil and below the airfoil. What do we know about pressure gradient forces? It's like the weather. If you have highs in weather or lows in weather, you have an air movement from the high to the low. That means when you have above, way above the airfoil, you have ambient pressure above there, and beyond the airfoil, you have ambient pressure as well. And you have fluid flow from high to low centers, and you look onto the direction of this pressure gradient forces, you can say that you have from high to low, that you have low pressure in this area. And the same below the airfoil. You have high, this direction shows from high to low. So you have high pressure gradients in this area. What does that mean to the airfoil? So we can now draw the pressure here on the above. You have ambient pressure plus some pressure which is caused to the pressure gradient force, and here and here you have ambient pressure plus the pressure which is forced by the pressure gradient forces. So what does that mean to my airfoil? To my airfoil, that means that you have an area with low pressure above the airfoil and an area with higher pressure compared to the ambient pressure in this part of the airfoil. And this pressure difference results in a force which goes up, and this is the force you're looking for. Okay? So this is a 2D way to explain it. In 3D, it's more complicated. So I draw the little airplane, and I draw the streamlines, which was following the curvature. So the air flows down behind the airfoil wing, okay, and then it will come up somehow, and you have a 3D circular air movement, which results in a 3D circular movement in the air, in a 3D or at the airfoil or airplane. So that means that physics is a lot more complicated than we really want to have it. So for an engineering process, we'll work with that, but it's more complicated. So I hope this explanation is okay for you, and you know how it works.
Thank you very much, Claudia. Now it's really the first time I know why airplanes do not crash. And that's also a good way to explain how wind turbines work, why the rotor is really rotating. And in the next video we then will show, but there is still a difference between airplanes and wind turbines. That will be next. Thank you very much.